Yes, students, good morning. In the previous video, we discussed about the oscillator concept, what exactly oscillator is and how the oscillations are produced and what are the criteria which is required to produce the oscillations using RC phase in case of the Barkhausen criterion. What are the different criteria to produce the oscillations and other things we discussed. Okay, now in this session, we will discuss about the RC phase shift oscillator. We have various types of RC phase shift oscillator which you already studied in analog electronic circuits, that is RC phase shift circuit using a transistor bridge. Okay, so here in this particular module we will be discussing about the RC phase shift oscillator using the operational amplifier circuit. Okay, here we are generating the oscillations using the operational amplifier. Okay, here in this case, as I said in the previous video, so to produce the oscillations there is a phase shift around the loop should be 180-degree. Okay, and the forward path gain and feedback path gain should be is equal to 1. Okay, so phase shift around the loop is 160 means, so here we have a inverting amplifier. If you give a sine wave, you will get the inverted sine wave. That means if you give a sine wave, you will get the inverted sine wave. That means you will get 180-degree phase shift is produced from this particular op amp. Okay, so we want another 180-degree phase shift. That 180-degree phase shift is achieved by using this RNC ladder network. Each RC combination will produce the 60-degree of phase shift, and the total phase shift around the loop will be 180. So 180 phase shift from this inverting amplifier and 180 from this RC ladder network. So 360 phase shift is produced around the loop. Okay, so the loop around the loop 360 phase shift is produced. So we have to calculate is now the forward path gain and the feedback path gain should be 1, that we have to do here. Okay, so for that purpose, for the simplicity and operations, this RC ladder will be taken here. This RNC ladder network, I have redrawn it like this. Okay, redrawn it like this, and the capacitance value I am indicated as 1 divided by SC. Okay, 1 divided by SC. So the output of the inverting amplifier, it is V0, that is V0 of S. So next it is V1 of S, V2 of S, and VF of S. That means it is a feedback voltage. So that is a feedback voltage. Okay, and all the resistance values are as it is. I am keeping only, I am changing the capacitance into 1 divided by S. So here first one is I1 of S is equal to, that is the current is this one, I2 of S and I3 of S. Similarly I3 of S is equal to I4 of S, I5 of S. Okay, that we will come back later. First we'll discuss about the I1 of S. This is I1 of S is equal to I2 of S plus I3 of S. So I am writing here from this ladder diagram. So at the KVL at V1 of S, you will get I1 of S is equal to I2 of S plus I3 of S. So similar, V is equal to IR formula, you write the I1 of S is equal to V0 of S minus V1 of S divided by 1 by SC. Similarly, I2 of S is V1 of S divided by R is equal to this one. Similarly, I3 of S is V1 of S minus V2 of S, this one, sorry, V1 of S minus V2 of S divided by 1 by SC. You will get I2 of S. Okay, now this is I values. Just go on simplifying this equations now. So this is the, from the ladder diagram we have written it. So from the ladder diagram, this is written I1 and I2. Just to simplify it the step by step. Okay, and simplify and calculate the V1 of S here. So simplification, you know, it is very simple simplification. Just taking the similar terms at one side and simplify it. So one step simplification, two step simplification, go on, simplify it and calculate the value of V1 of S here. So you will get the V1 of S, this one. After simplification of the above expression, you will get V1 of this one, and you call that as equation number 1. Okay, this simplification you just have to practice it, otherwise you will not get it. I have given the step by step simplification, so don't get confused. So go by step, you will understand the definition. Okay, now at node v2 you apply the KCL. Now at node v2 means, at node v2 is, this is your v2, so v2 i3 is equal to i4 plus i5. Okay, i3 is equal to i4 plus i5. So here it is. So i3 of s is equal to i4 plus i5. Similarly, in the above how you did, you just write the voltage equation. v1 of s, i3 is equal to v1 minus v2 divided by i4 is equal to this and this one. Just from the ladder diagram you just compare it. Okay, once again you go and simplify this step by step and you come across v1 of s. v1 of s, this you calculate it, call it as equation number 2. This is equation number 1, it is equation number 2. It is at node 1 v1 of s, it is at node 2, that is v2 of s, right? So now apply voltage divider rule at the Vf. Vf is what? This is the Vf. At this point, what is the voltage? You have to find out by applying the voltage divider rule. So after applying voltage divider rule, what you will get? Here it is Vf is equal to R into R divided by, here it is, so Vf of s is equal to R and capacitance is there, so Vf is equal to, okay, so R divided by, here this one, 1 R plus 1 by SC, that means R divided by R plus, this is the resistance and the total impedance. According to voltage divider rule, calculate the Vf of s. So here Vf of s, it is given like this, it is Vf of s. Vf of s is equal to R divided by 1 by SC into V2 of s. V2 of s. Now from this just rewrite this equation, you can rewrite for a V2 of s, calculate V2 of s. Now substitute this V2 of s in equation numbers 1 and 2. Substitute V2 of s which we calculated here in equation number 1 and 2. So this, call it as equation number 4, equation number 5. After substituting V2 of s, you will get these two equation 4 and 5. Now equate equation number 4 and 5. So these two equations you have to equate it. Equation number 4, equation number 5, you just equate here. Okay, and once again go on simplification. Each step by step simplification is given. It is very common mathematical simplifications. There is nothing rocket science involved here. So just go on simplifying these step by step. It is already given, just analyze it. So this is after simplification of 1 steps, 2 step simplification, 1 step simplification, 2 steps, 3 steps. Okay, like this you just simplify for Vf of s divided by V0 of s. After simplification you have to get the equation for Vf of s divided by V0 of s. So that is, you will get this equation. So by comparing equation number 4 and 5, okay, and simplify it and calculate Vf of s divided by V0 of s, you will get this particular equation, that is called as B. B is nothing but the feedback path gain. So we have taken a RC ladder network and we calculated the gain at that particular R and C ladder combination. So that is why it's a feedback path gain here. Okay, so that's feedback path gain B we calculated. So, and it's an inverting amplifier, you know that. So the amplifier which is used in the circuit is inverting amplifier. So gain of the inverting amplifier AB is equal to minus RF divided by R1. So for the oscillator to produce the uniform oscillations, what is the criteria? A into B is equal to 1. So A into B is AB into B is equal to 1. Okay, AB is once again RF divided by R1. So B is you calculated here. So substitute, okay, is equal to 1. Right, here we have, instead of s you substitute j omega. S is nothing but a capacitance, so you could substitute j omega, and j square is equal to minus 1 and j cube is equal to minus j. This is the fundamentals it is. So j square is minus 1 and j cube is equal to minus j. This is a fundamentals. Okay, substitute these values, that is s is equal to j omega, j square is equal to -1, j cube is equal to -j in this equation, that is this equation. Rewrite it. Now rewrite the equation. So after rewriting, you'll get this one, minus rf divided by r1. So r cube c cube s cube, r cube c cube s cube, it is s is equal to j omega. So j cube minus j cube is minus j, so it is j minus j r cube c cube omega cube. Similarly, this is multiplied this side, okay, and you will get this equation equal to this one. Okay, now take out the real part in this particular equation. What is the real part? It is 6 r square c square plus 1 is equal to 0. So real part, only the real part you just take. This is your real part. So 6 into r square c square omega square plus 1 is equal to 0. That's a real part. Okay, so simplify it for omega. So simplify the real part. So you just keep omega is as it is. You just send this to this way, that is 6 r square c square omega cube is equal to 1. So omega square is equal to this one. Okay, and omega is what? Omega is 2 pi f naught. Omega is 2 pi f naught square is equal to 1 divided by 6 r square into c square. Okay, 2 pi you just take it in the numerator. So f naught square is equal to 1 divided by 4 pi, this one. So f naught is equal to 1 divided by 2 pi root 6 into r into c. F naught is equal to 1 divided by, this is the equation to calculate the frequency f naught of the RC phase shift oscillator. Now consider only the imaginary terms. Sorry, yeah. Consider only imaginary. Real part you calculated, find it out, and f naught you calculated. Now imaginary part is this, j is imaginary, this is imaginary part, and this is also imaginary part. So minus rf divided by r1 into this, okay, and this plus this is the imaginary parts. Okay, so here rf divided by r1, it is as it is, it will be, okay, and send this to the denominator here. So if you send it, so it is 1, this and this gets cancelled, 1, okay, and it is 5 divided by r cube is there, here r c w is there, 1 r 1 c and 1 w will get cancelled, so 5 divided by this you will get. Okay, now 1 minus 5 divided by rc, omega is 2 pi f naught square, you keep it as it is. So once again 1 divided by 5 divided by r square c square into bracket of 2 pi as it is, f naught is you calculated here. Okay, substitute that value, okay, and simplify it. After simplification you will get 1 minus, here 2 pi gets cancelled, 2 pi gets cancelled. Okay, here rc and rc, it is square, so rc square gets cancelled. So it is 1 minus root 6, root is also cancels, root is also cancels, so it is 5 divided by 1 by 6. So the 6 goes to the numerator, 5 into 6 is equal to 30. Okay, it is 1 minus 30. Okay, so minus rf divided by r1 is equal to minus 29 here. So rf divided by r1 is equal to 29. Okay, this is the what is that, RF feedback and gain of the RC phase shift oscillator, that is RF divided by R1 is equal to 29. So in the exams you may get, prove that RF divided by R1 is equal to 29, or you may also get the question like with a neat sketch explain the working principle of RC phase shift oscillator and also derive the expressions for the f0 and gain. Okay, in that case this is how you have to derive it. So it is somewhat little bit lengthier derivations, and all the steps involved in this derivations are clearly given. Just go on solving it, the derivation step by step. So if you got any doubts in between the steps, you just call me for clarifications. Okay, I hope there is no as such complicated derivations. involved here. So every step, each step is given in the this part. So just go step by step and derive the expressions. Still, if you got any doubts, you can call me, I'll clarify it. Okay, thank you.